Alright class, in this video I'll be doing the first example from section 6.3. Graph the function f of x is equal to negative 3 raised to the x plus 1 power plus 9. Alright, the first thing we're going to do is we're going to determine the domain of this function, and if we look, that is an exponential function, and the domain of that exponential function is all real numbers. Next, we're going to find the intercepts of this function, starting with the x. And the x-intercept is the value of x where y, or in this case the function, is equal to 0. Solving for x, we're going to subtract 9 from both sides. Then we're going to write 9 as 3 squared. And since both exponential terms have the same base, we can conclude that 2 has to equal x plus 1, in which case x is 1, so the x-intercept is 1, 0. Next, we're going to find the y-intercept, and the y-intercept is the coordinate where x is equal to 0. So we're going to substitute 0 in for x, like such, and solve this expression. So there's the y-intercept. The y-intercept is 0, 6. Next, we're going to find the horizontal asymptote. And the horizontal asymptote is the constant term at the end of this exponential function. And the reason why that's a horizontal asymptote is because negative 3 x plus 1 cannot equal 0. So if negative 3 raised to the x plus 1 power cannot equal 0, then the function cannot equal 9. So I'm going to put a dotted line where the line y is equal to 9 is located. Now we only have 2 points here, but we can find a third. So what we're going to do is we're going to pick the coordinate that makes that exponent 0. And in this case, when x is equal to negative 1, that exponent is equal to 0. So f of negative 1 is equal to negative 3, negative 1 plus 1 plus 9, which is equal to this, which is equal to negative 1 plus 9, which is 8. So the additional coordinate is negative 1, 8. Now we can sketch the function. And this is the graph of f of x.